system of forces. So recall I said that if you have a force that is inclined, so this 10 Newton force is inclined at an angle to the horizontal 30 degrees. So this horizontal x-axis, the angle is just sitting on it. 30 degrees is just closest to this horizontal x-axis. So closest is like adjacent. So it's just the angle is just adjacent to this the x-axis. So adjacent is related by cosine. So cosine is adjacent of hypotenuse. So basically, the horizontal component of this 10 Newton force is 10 cos 30. That means the vertical component of the 10 Newton force will be 10 sine 30, because this side is opposite to this side, and so opposite is related by sine. All right, so let's get the sum of forces in the horizontal direction. So this symbol means summation. That looks like an E. Summation of the forces in the x direction. That's the horizontal direction. So summation of forces in basically the sum of horizontal components of the forces, the horizontal components. So 10, we just said this force is 10 cos 30. 10 cos 30. So you have 10 cos 30. Then you have your 15. So your 15 Newton force is also inclined, and 60 degrees is just adjacent to the horizontal axis. So 15 cos 60. So we're adding it up, plus 15 cos 60. That's the horizontal component of this 15 Newton force. And then the 12 Newton force. 12 Newton force is inclined at 40 degrees to the horizontal, but it's in the negative of x. So it's minus that, minus 12 cos 40. All right, so let's look at these. So those are these horizontal forces in the horizontal component. There's the horizontal direction. 10 cos 30, 15 cos 60, minus 12 cos 40. Because this force, this is the horizontal component of the 12 Newton force. This is vertical. So the horizontal component is in the negative x direction. So this is negative x, positive x. So that's why it's minus 12, because in the negative direction. The others are positive. Okay. So now let's look at the summation of the forces in the vertical direction. Of course, 10. This one will be 10 sine 30. 10 sine 30. 15 will be 15 sine 60, but negative because this is acting downwards. The vertical component of this 15 Newton force is acting vertically downwards, so it's negative, minus 9. Minus 9, this is minus 9. It's given from the question. So it's already downwards direction, so it has been minus, negative. And then 12 sine 40, this 12 Newton force, this is vertical component, so it's positive, up, plus that. So if you sum all that with your pointer to your calculator, you have 6.97 Newton for the summation of horizontal forces, and then minus 9.28 Newton for the summation of the vertical forces. So you put that into, so this is sum of horizontal, sum of vertical, right? So basically we have our the sum of all these forces. The sum of all these forces, that is the horizontal component of all four forces. This, and this. This is the horizontal component of all of them. 6.97. Excuse me. So we can show it in this line. Okay, horizontal. It's pointing it's positive x. So it's a positive horizontal force. So it's going into eastward. Then the negative vertical force is going this way. Okay, so we can use it to form a right angle triangle, because this side is opposite to this side, opposite and parallel. So we can form a right angle triangle like this, and then that means that this is our resultant. Just look at this and this side and this. This must be the resultant force. Okay, so R is our resultant force. Okay, so we have the horizontal components, sum of the horizontal component 6.97 Newton, the sum of the vertical component minus 9.28, and it's acting southwards because northwards is positive, but this is negative this way. That means then logically this should be the resultant, a single force that represents in magnitude and direction the effect of these two forces. So you can form a right angle triangle. Through it can form a right angle triangle. This side, we've added in this side, is parallel and opposite. It represents this vertical, the vertical